So here's a series that we can integrate. Obviously, the directions right there say integral test. One thing that I want to change is find the sum. That should say estimate the sum. Okay, so first of all, the integral test. So notice that this starts at 2 because 1 would make it undefined. Also 0 would make it undefined. So we're going to integrate from 2 to infinity. And the function, just change those n's to x's, x squared minus x in the denominator. And then that looks like we should factor it. So integrate. And then the bottom could be factored as x times x minus 1. And now it's time to do some pre-calculus and do the partial fractions for that. So if I do the pre-calculus right here, it looks like 1 over x times x minus 1 can be rewritten as two fractions. One of them will say a over x, and the other one b over x minus 1. And then when you multiply both sides by the least common denominator, which is the x times x minus 1, that's definitely going to simplify things. And on this side, these two cancel, so all that's left is the numerator. For the a, we'll just have a times x minus 1. And then we'll have b times x. And at this point, what I prefer to do is just pick numbers for x, like nice easy numbers. What if x equals 0? So the left side will have 1. For the a, that would be 0 minus 1, so that means the a is multiplied with negative 1, and then it's going to be b times 0, so that is leaving us the answer that a equals negative 1. And then go back to that equation and substitute, let's say x equals 1. So then we would have a times 1 minus 1, and then we would have b times 1. So once we simplify that, that tells us that b is equal to 1. So then I need to go back to where I made a bit of a mess with my cancellations, and then substitute that a is going to be a 1. Oh, excuse me, a is going to be a negative 1. Trying to get my pen to work. And that b is going to be 1. So this one is going to be integrate negative 1 over x, and this one is 1 over x minus 1. And don't forget, the limits are 2 to infinity. So integrate from 2 to infinity. It was the a over x, and the a turned out to be a negative 1. And then it was the b over x minus 1. And then integrate those two as if they're two simple integrals instead of one complicated one. I just want to look back and make sure that I got the a and the b in the correct place. It looks like I did. And then this is a job for natural log. So the first one will be negative 1, and then 1 over x, the antiderivative is natural log of x. For the next one, that's going to be the natural log of x minus 1, and then evaluate that from 2 to infinity, but not beyond. So when we use infinity, that's going to be the negative natural log of infinity, and that is going to turn out to be negative infinity, plus the natural log of infinity minus 1, that is going to turn out to be positive infinity. So this even deserves a red pen. So this turns out to be negative infinity, and this turns out to be plus infinity. So they are going to cancel each other out and equal 0. Now, you also have to consider, are they going there at the same rate? Because they're both natural logs, they both have the same size engine, they're both going at the same rate, so they're going to cancel each other out. So you can't always say negative infinity plus infinity equals 0, because if let's say this one instead was x squared. Well, x squared is a more powerful function than natural log, and it would dominate. And in that case, the answer would be infinity because the x squared would dominate the whole problem. Okay, so that's just a small detail that comes up later, but I just wanted to point it out right now. Since both of these are natural log, the negative infinity and positive infinity are going to cancel each other out. And then, what about the 2? So then I need to go minus, and then it's going to be negative the natural log of 2 plus, then natural log of 2 minus 1, so just substituting the 2, so that's going to be natural log of 1. So the negative infinity plus infinity, that's going to be 0. And then this will be negative negative, so that's plus the natural log of 2. And then the natural log of 1 equals 0. So the whole thing equals the natural log of 2. And then of course everybody knows that equals 0.693. So my estimate is that the answer is going to be approximately 0.693. That's just an estimate. And since that is a finite number, I can say therefore it converges. And when you do the integral test, this is a pretty rough estimate. The answer might end up to be like 1.2 or might end up to be 0.42. So the next thing I'm going to do is use some sequence on the calculator. So go back to the original problem. Thank you. Orange sounds great. So go back to the original problem and use the calculator to find out approximately how much is this sum. So go over to the calculator and do the second list, math, create the sum, second list, operations, create the sequence, and then the function is 1 divided by, I'll use x as the variable, x squared minus x, and that needs to be in parentheses, and then tell the calculator x is the variable. And then this one started at 2, and then go to infinity. So I don't have infinity on the calculator. I'll just use a big number like 1. So right there, I skipped a step. The last part is you can tell it that the increment is 1. But if you leave off that last 1 right there, then the calculator will assume that you mean 1. And so it gives us 0.99. All right, then what if we use more of these and you have it add up, let's say up to 500. So now I get 998, and my brain is starting to tell me maybe the answer is 1. How about if we do, can it do 900? Uh-oh, I think the answer is 1, 0.999. Let's try another. Can the calculator do 999? And you still get the answer 0.999. I'm pretty convinced. I believe the answer is actually 1. I just want to try one more. What about if I do 1,000? I'm trying to find where's the red line between what the calculator will do and where it gives up. So if you insert a 0, can it do 1,000? Yep, it can. So it's still 0.999. All right, for those that are still watching, I'll try one more. How about 1,500? Oh, the calculator said no, that's too much for my little brain. So I'm going to say that the answer is 1 because I got 0.999 repeatedly. So using the sum sequence, the 1 divided by x squared minus x with respect to x going from 2 to the most I could do is 1,000, and then that equaled 0.999. So then I'm saying that I think the answer is 1 for my estimate.